Assalamualaikum everyone, my name is Nasrul bin Ahmad Zazali, and I will be presenting to our project title is Type of Flower Recognition using CNN. This project was done together with my team, Siti Aisyah and Anisha Vika, under the guidance of Madam Haja Izati. This is our member, which is 3 members. So the data explanation for data set we are using is flower data set to be recognized using convolutional neural network CNN, and the data set consists of 4 different type of flower, and the image are categorized according to the respective clusters, and all images are resized to 100 times 100 pixel using MATLAB for uniformity and to optimize training performance. So in this is set of data set of 4 type of flower, which is one flower consists 200 images, and the sizing is 100 times 100 pixels, and it's using MATLAB to resizing the image and improve to model performance. So Daisy 200, Roses is 200 image, and Sunflower 200, also Tulip 200 images.
I will explain for the training piece in our CNN model. For the first experiment, we insert a baseline model. There are two conventional 2D layers that being inserted with the 316 padding and SEM, and the second conventional 2D layer is a 332 padding and SEM. And also we put the initial learn rate, the higher learn rate, and also we put the max epochs, which is a fewer epochs. As we can see, this is the training progress figure, and there are validation accuracy with a 70.5%. So the figure 1 shows it classify the picture as a daisy with 52.26%. The second highest is tulip, 39.53%, and the third higher is roses, 7.86%, and the lowest is sunflower, 0.35. For our second experiment, we insert the larger filter size, which is 5x5. We put the size, we change the 3 size into the 5, and then the result that we get from our training progress is the 72.5%. And the figure 1 shows it classifies the pictures as a daisy, which with 97.07%. And the second highest is a tulip, 2.92, and roses with 0.01, and sunflower is the lowest with the 0%, in which that we can conclude our MATLAB still cannot predict the picture correctly. For experiment 3, we add a third convolutional layer and also a dropout layer. So this is our third convolutional, and this is our the dropout layer. So from the result of our training progress, we get a 75%. And the figure show that it successfully classified the pictures as a tulip with 99.01%, and the sunflower is not the highest one, but it's still the lowest one with 0.88%, and then daisy with 0.1, and the last one is roses 0.01. For our experiment 4, we change our pool size with 3x3, and the result from our training progress with a validation 73.5%, and the figure shows it also get to classify the pictures as a tulip with 82.64%, and then the second highest, not the really the highest one, is a daisy, 16.47, and then the lowest is sunflower and roses with a different percentage.
These tests tried using a very strong learning rate of zero point 0.1 with only 5 training cycles. The model got trained super fast in just 22 seconds, but the results weren't good. It only got 25% accuracy, basically just guessing randomly between the flowers. The prediction scores all came out around 25% for each type. This shows that when the learning rate is too high, the model can't learn properly. Here, the learning rate was made much smaller at 0.0005 and given more time to learn with 30 training cycles. The training took longer at 2 minutes 43 seconds, but the results improved dramatically to 77% accuracy. The model became much more confident in its predictions, especially for tulips, at 87.56%. This proves that slower, more careful learning works better. These tests use larger groups of 128 images at a time during training. While it trained faster at 1 minute 52 seconds, the accuracy dropped to 733%. The predictions became less sure of themselves, like only being 50% confident about sunflowers. Bigger batches seem to make learning less precise. Using smaller groups of just 32 images at a time keep their training time about the same at 1 minute 54 seconds, but accuracy jumped to 79.5%. The model got really good at spotting tulips, reaching 6 reaching 96.52% confidence. Smaller batches clearly help the model learn better. An additional learning layer with 64 nodes was added, training to 2 minutes 3 seconds, and accuracy stayed strong at 78%. The model became extremely confident about tulips at 98.51%. The extra layer helps, but might need more data to work perfectly. The final version combined all the best settings: a bigger 128 node learning layer, very careful learning rate of 0.0003, and 35 training cycles. While the test accuracy was 76.5%, it performed amazingly on new flower pictures, getting 96.7% on tulips. This model works great for real-world use.
Moving next to the testing phase, which is for sunflower, roses, tulip, and daisy. So this is MATLAB, our coding and flower detection. This is our title for this coding only. So for the first step, I will load and split data set from the data path. So this is for training actually, but for the testing, I am using this for images, daisy testing, peach rose, sunflower testing, and tulip testing. So these are for images. So the step two is experiment 10 coding for parameter. This is include convolution to the layer, which put 3, and row up layer, and also increase from fully connected layer 64 to 128 using FC. So this is set training option. This is the visual option for the initial learn rate with 0.003, so estimate minutes or about 3 minute 50 seconds. And this is match epoch mini batch size 64, and validation I am validation frequency 30. And also for the train to work, we use net train work, also include in the lab. And for the test new image, this is when we push path image from this pictures.jpg, it will show the image. So we proceed to the testing. So I will fast forward. So the accuracy for the rosters is 99.16% confidence. So this is show that accuracy for the rosters type of flower is 99%. So it's not like tulip, daisy, and sunflower. So we moving to the testing of daisy. So this is testing for daisy. So maybe like I testing again many time, but I got a daisy like 70%. But in the report I got the number that I got. But in the testing we got 59%. Well, so moving on next to the sunflower. So the accuracy we got 80% on 50. So the accuracy we got same like previous validation accuracy 80%. So this is conclude that sunflower is 99.94% of confidence. So the prediction will choose the sunflower because the sunflower is 99%. So this high one. So we moving on the last, which is tulip flower.
So this is last one, which is tulip. Is 99.84% is confidence. So the prediction is the system choose tulip. So the prediction is the correct. So the validation accuracy is 77 and 50%, 0.50%. So that's all for the four testing, and the estimate elapsed time almost majority is like 6 minutes, and that's it. Thank you very much.
Conclusion, in our experiment 10, our network achieved the validation's accuracy 77%, which is making it the most optimal model. Therefore, this network was used in the testing phase to evaluate the real-world flower. The testing phase result confirmed the effectiveness of our CNN model, and when we testing our model with a new image of tulip, the model can predict our tulip with uh, can predict the image as tulip with 99.97994% accuracy, in which make it as a high level of precision, and we can confirm that our training process was successful, and our CNN model is also capable to recognize the types of flowers. And that's all from our group. Thank you for lending your ear and have a good day.